Bonjour, welcome to Wahsa Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher, Bronwyn Slate.
Unfortunately, this week you cannot participate live as our studio is under some construction and you can't call in. So this lesson is pre-recorded, though we are broadcasting on the radio at 91.9 FM and on the television at Bell Express View channel 972. Usually you will be able to join live through the Zoom link or call into the Wahsa studio to ask questions, but for this week, that is not a possibility. Our classes are scheduled Monday through Thursday from 10 until 11 in the morning, and we are in our first week of our 9-week course. So to know what work to submit as we go through our course, the support questions, the ones with a little pencil icon, are not for marking. You decide which ones and how many to do. If you understand a concept, feel free to skip questions. You don't have to do them all just because they are there. If you need more practice, let me know and I'm happy to send you more practice. All of the answers are at the back of your book for the support questions, so please check your work to make sure you're on the right track. The key questions, the ones with the little key icon, are the ones to submit for marking. So please do all of these questions showing all of your work, your steps, and your thinking. This way I can understand what it is that you understand, and I can support you and help you if you are making errors. So then how do you submit your work for marking? Well, there's 3 methods. The first method is to scan and send your work electronically. You can scan your completed work through a device. If you have an Apple device, the Notes app has a scan function, and if you have an Android device, the Google Drive app has a scan function. These are free apps that generally come with these devices and so are already on them and are fairly straightforward to use. If you need some support learning how to do that, I have videos on my YouTube channel that walk you through step by step how to use both these individual apps. They're under my playlist called the Tech Tutorials, and you can follow there along to learn how to do that. Once you have it scanned, you can then send it either by email to studentwork@nnec.on.ca and CC it to bronwyn.slate@nnec.on.ca, or you can send it through Facebook Messenger, where my name is B. Slate Wahsa. A quick moment of recognizing why I'm suggesting scanning versus just taking a picture. You can take a picture if that is what works best for you. If that's the only option that you have, that's fine. But if you scan using an app on your phone, it means that it's easier to create one file with all your pages so we don't lose anything. It's faster because it simplifies the image, and that makes it a smaller file, which is easier to send. This is why I encourage scanning, but again, if that doesn't work for you and you need to take pictures, if that's the best way for you to send work electronically, that is okay. If you want to learn how to scan with your smartphone, with your device, I'm happy also to walk you through that and to support you. If watching the videos isn't a great option for you, just let me know. I'm happy to support however I can. All right, so our second method is to drop off your work in Sioux Lookout. We have an outdoor mailbox at our location 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. So just put your work in there and we'll get it back to you as soon as possible. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students are also welcome to hand in their work by fax if that's something you have access to. We just ask that you give us a call or send me a message to let us know that you have sent a fax, as we've had some instances where things get faxed, but they don't get received. So we want to make sure that we get your work. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name B. Slate Wahsa. You can friend me on Facebook and subscribe to my YouTube channel, and then every time I upload one of our radio Zoom classes videos, you will get a notification. so that you know it is there. It's easy to find. As I've said, all of our Radio Zoom classes are recorded and posted to YouTube shortly after broadcasting. So everything is there for you to find as accessible as possible. Also, on my channel, there are short videos that explain common errors and confusing concepts. So this is a really good place to go if you are struggling with something, or if you're feel like you're missing a piece that isn't necessarily a new concept, but is something that you've struggled with in the past. There might be something there on my YouTube channel that addresses this and just makes it a little bit easier to find that help opposed to doing a general online search. Math is a really visual subject, so I strongly encourage you to access the videos. Listening to me only on the radio is not going to give you the full experience, and things most likely will not make as much sense as if you access the videos and see what I am talking about on the screen. If you cannot join me live through Radio Zoom, if you cannot access the YouTube videos, you don't have reliable internet, so those are not options, let me know and I'm happy to send you a copy of all of our recordings so that you still can get the full experience and set yourself up for the most success. If any questions or concerns, please reach out and contact me. My primary focus in my position is to support you, my students. You can send me an email at bronwyn.slate, that's spelled BRONWYN.SLATE@nnec.on.ca. Connect with me through Facebook, where my name is B Slate Wahsa. B Slate is all one word, second word Wahsa. Give me a call at the office at 807-737-1488 or toll-free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., though I teach from 9 until 11, so that's not a great time to try to get a hold of me.
Great. So we are continuing with lesson 1 that we started yesterday and got about halfway through. So we're continuing to look at quadratic transformations today. So a reminder that our learning goals for this lesson are that you'll be able to recognize the important parts of a quadratic graph, specifically when it represents a real life situation, and you'll understand how A, H, and K change a quadratic graph, which is also called a parabola. You know you've met these learning goals because you can find the A, H, and K value in a quadratic equation, and you can explain the difference between a vertical reflection, a horizontal shift, and a vertical shift. But first, let's activate your brain with a bit of mental math. So I am not a fan of Mad Math Minutes. They cause stress in most folks, more folks than not, and they don't actually teach any skills. So instead, we work on developing skills in our course that you can transfer to various situations and use however makes you most comfortable. So our question today is 36, take away 19, and we're going to introduce the concept of an open number line. This is not something that I learned in elementary school, and I never used in high school or university, but it was really, really useful when I was introduced to it partway through my teaching career. And this is the idea that you take a number line, take a line, and you don't write your numbers on it, you just use it as a guide. So we still think of the fact that negative numbers are on the left and positive numbers are on the right, and 0 is somewhere in between. But you don't have to, it doesn't have to be precise, it's just a tool for visualization. So I'm going to say that 36 is where I'm starting, and I want to take away 19. And I'm going to use this tool to help me take away friendly numbers in order to do this subtraction. Subtraction is something that many, many people struggle with, and many, many people make the same errors over and over again. So having multiple tools is really useful. So 36, take away 19. Well, I'm first going to take away 10. So 36 take away 10 is 26. Okay, so I've already taken away 10 out of my 19, and I only need to take away 9 more. But I'm not sure how to take away that 9 more. So I'm going to first take away 6, because that is a friendly amount, because that gets me down to 20. And now I've taken away 16, and I need to take away 19. So that means I need to take away 3 more. So if I take away another 3, I get down to 17. 20 take away 3 is 17. So 36 take away 19 is equal to 17. So as you can see on my open number line, my jumps are just sort of rough. It doesn't really matter if they're precise or not. It's just really a tool to think about taking jumps. You could have also done this in a different order. You could have taken away 6 first, then 10, then 3. You can do various different things. You could have thought instead of taking away 16 first, or like you can do different things depending on what makes the most sense for you. It's a really great tool, and we'll be using it again throughout the course. All right, so then let's do a quick a quick review of what we talked about in our previous lesson. So a reminder that the parent function y equals x squared is what we're basing these quadratic transformations on. So this is when we choose various x values. So for example, I've chosen x values -4, -3, -2, -1, 0, 1, 2, 3, and 4. And I input them into the equation y equals x squared. So for every x, I get a corresponding y. So when x is -4, -4 squared equals 16. So y is 16. When x is -3, -3 squared is 9. So y is 9. And continuing -2, y becomes 4. X equals -1, y is 1. X is 0, y is 0. X is 1, y is 1. X is 2, y is 4. X is 3, y is 9. X is 4, y is 16. And then we can plot these points and we get our parabola shape, this U or V shape that opens up. And we can see that that goes through the origin, goes through 0, 0, and is all above the x-axis. And it's symmetrical, so it reflects along the y-axis. You can see that the points are all the same on both sides. So the general form of that, of our parent of a quadratic, is y equals a times x minus h quantity squared. So that means that the x minus h is all squared, plus k. So that's every quadratic comes in this, could be written in this form. For the parent function, a is equal to 1, h is equal to 0, and k is equal to 0. So that's how we get y equals x squared, because y equals 1 times x minus 0 all squared plus 0 is equal, if we simplify, to y equals x squared. And that is the basis of what we're talking about. So then we looked in our last lesson, we examined the k value, which showed us that k represents a vertical shift. So shifting our parabola up or down, depending on if our value is positive or negative, our k value. So if we have a positive k value, then it shifts our whole parabola. Every single point gets moved up 3 points. So our whole parabola gets shifted up 3 points. And if we have a negative k value, then our whole parabola gets shifted down. So that's how it works for the vertical shift. And that's what we reviewed last time, or learned last time. So now we're going to dive into some new concepts, continuing with this same lesson 1, but we're going to look at the h and the a values now. So the h value is what we're going to look at first, and this is on page 4 of your IL booklet. Remember, I did things in a slightly different order. So this, looking at h, is on page 4. And h in our general formula is y equals a times x minus h. This is the part that we're looking at, all squared plus k. So for our example, we're going to look at where h is equal to 1. And so that means that we're going to say that we have y equals x plus 1 all squared equals y. Sorry, my brain just didn't think for a second. So what this is, what if we're thinking back to the fact that we were relating in our last lesson, we were relating area to side length. This is the, so if we ask our question, we talked about how in math many times we just ask the question, what if? So this is the idea, is what if we add a number to the side, sorry, I'll read this again. What if we add a number before we square the sides? How does this change the pattern? So if we increase or decrease our side, if we increase our side length, how does that change our pattern? So looking at our little square pattern where we had before. So first we have x equals 0. So our side length is 0. But we're going to add 1 to that. And so 1, each side gets added 1. So 1 plus 1 equals 0 plus 1 equals 1. All squared equals 1, because 1 times 1 equals 1. So if x is 0, for this formula, our y is now equal to 1. But, so now let's keep looking. So if y is our area, then we change our x equals to 1. So our side length is equal to 1. But in our new formula, our new equation, we have 1 plus 1. So we're adding 1 to each of our sides. So that means that we now actually are squaring 2, because 1 plus 1 equals 2. So that our total area is equal to 4. So next, if x equals 2, if our side length equals 2, but in our new equation, we're saying 2 plus 1, we're adding on an extra 1 unit to our side length. So that means that our side length is actually 3. So 3 squared is equal to 9. So when x equals 2, in this pattern, our area, our y, is equal to 9. In x equals 3, our side length is 3 plus 1, because that's what we're doing. So that means that our new side length is actually 4. So our area is 4 squared, which is 16. And then finally, if x equals 4, then our side length now is going to be 4 plus 1, which is equal to 5. So our area is 5 squared, so that is equal to 25. So we can see that our pattern has shifted slightly. Our original our parent function, y equals x squared, is this line in black that we've seen. And we can see that each of our y values has shifted. So it's taken a little bit longer. No, we've gotten there a little bit faster. So when x is equal to 0, now we're at 1. And when x is equal to 2, we've got to 4. When x is equal to 3, when x is equal to 2, we're already at 9. And when x is equal to 3, we're already at 16. So this one is one that's really tricky because we have shifted our parabola, but it's not in the direction that we would expect because we added 1 to everything. And so I would feel like we wouldn't want to shift it over to the right, but it's actually shifted to the left. So we're going to keep looking at that everything happened a little bit faster, and so we got to it quicker. So now we're going to examine H if we were decreasing our amount. So what if we subtract a number before we square the sides? How does this change our pattern? So we're decreasing our side length, and how is this going to change? So if x equals 0, well, if x equals 0, then we have -1, which doesn't make any sense in terms of our side length, because if we're having having a negative side length doesn't make sense. So we're going to ignore that for right now, and we're going to continue with the rest of the pattern. So if we have x equals 1, we had a side length of 1, but then we are subtracting 1. So that means that we're actually canceling out that side length. So we have 0. So 0 squared is 0. So when x is equal to 2, our side length is 2, but we're subtracting 1. So now that's 2 take away 1 is 1. So we end up with a side length of 1. So we have 1 and 1, which means that we have a area of 1. When x is equal to 3 and we subtract 1, so we're subtracting 1 unit from our side length. So if we do 3 take away 1, we get 2. So our side length now is 2. And so that means that we have a total area of 4. When x is equal to 4, we take away 1 unit. So that means that we're now looking at a side length of 3. So 3 squared is equal to 9. Our area is 9. So then if we graph those points, we see that all of our points compared to our parent function have shifted to the right. It's taken us a little bit longer to get to them. So when x is equal to 1, we're at 0. When x is equal to 2, we're at 1. When x is equal to 3, we're at 4. When x is equal to 4, we're at 9. When x is equal to 5, we're at 16. It's taken us a little bit longer to get to each of those amounts. So let's look at, we're going to look at a link here where we can change our h value. So we're leaving our a value as 1 and our k value as 0. But if I change my h value, as I get positive, my h moves in a positive direction. It moves over. The trick is, this is where it gets really confusing, is that in here, in my equation, my h looks negative. So my equation is y equals x minus 4 squared. But 4 is actually my h value. The minus sign is already in the equation, and so that isn't something that, it isn't part of my h value. So my h value is positive 4. It just looks negative because the negative is already part of the equation. So when h is positive, we move to the right. We move in the positive direction. However, in our equation, our value looks negative, so it's kind of the opposite. So if I move my h down and I get a negative h value, I'm moving to the left, I'm moving to the negative parts. But if we now look at my equation now says y equals x plus 2.8 squared. And so it looks like it's positive, but my h value is actually negative. This is something that people mistake all of the time. This is something that's super confusing for folks. So it's not just you, if that's confusing. So h is the value of a horizontal shift. That hopefully makes sense, is that we're moving our parabola, we're transforming our parabola by shifting it back and forth along the x-axis, moving it to the left or to the right. So if we have a negative h, we're moving to the left. And if we have a positive h, we are shifting to the right. So the trick is that it looks different in the general form. So here on my screen, I have my black line is my parent parabola, my parent function, y equals x squared. And here, my yellow function is y equals x plus 1 all squared. Remember, this is what we just practiced. We went through all of those squares to see how that happened. And we got this yellow formula. Sorry, this yellow line. So h, even though it says x plus 1, h is actually negative 1. Because in our general formula, the equation is minus h. So here when it says plus h, that means we're actually subtracting a negative to make it plus. So that means that h is actually -1. And then we shift left 1 unit for every point. In the second part here, where we have the purple parabola that has shifted everything right by 1 unit, our equation is y equals x minus 1 all squared. And here h is plus 1. Even though it says that it's negative in the equation, it's actually a positive 1. It's the opposite sign than what's in the equation. And that means that we're shifting all of our units right. So the h sign in the equation is opposite than what you expect. So when you were looking at the equation for h only, not for k, not for a, for h only, the h is the opposite sign than what you see in the equation. So when you look at the general form, when you look at the form of your equation and it says x plus 1, that means that h is -1. Here, when it says x minus 1, that means that h is plus 1. So this is super important to remember, as it's confusing and annoying. If you just need to remember that it's opposite, fine. If you need to go back and look at the squares to understand why that makes sense, go for it. If you want to talk to me about it, feel free to call me, we can chat. So let's practice. Let's do some practice questions and look at how the parabola shifts and what the h value actually equals. So A, we have y equals 4 times x minus 3 squared plus k, plus 6. So we're just looking at the h value. So h is the part that is inside the brackets, where it's how we're affecting x first. So here it says x minus 3. That means that h is plus 3. It is the opposite sign than what is in the equation. So that means that we are shifting right. Three units. All right, B, y equals negative x plus 25 all squared plus 100. So again, h is the part inside the brackets with the x. So here h says plus 25, that means that it is minus 25. H is actually minus 25, even though it says plus 25 in the equation. So we are shifting it left by 25 units. C equals y equals x minus 17 squared minus 42. So h is in my brackets with the x. So here it says x minus 17. That means that h is equal to plus 17. So we are shifting right. And D, y equals -1 times x plus 5, quantity squared, minus 50. H is a part inside of the brackets with the x. So h is x plus 5 means that h is minus 5. So we are shifting left 5 units. So that's how you figure out how you're shifting in from the equation for your horizontal shift. If we want to graph that, so we have our practice question 2 is graph the following functions. A, for part A, y equals x minus 2 all squared. So h, because it's x minus 2, that means that h is plus. So we are shifting right by 2 units. So I'm going to take all of my points and I'm going to shift them 2. So I'm going to look at 0, 0, and that I'm going to move over to the right 2 units, 1, 2. And then I'm going to look, and 1, 1 is my next place that my parabola crosses the line really nicely. So I'm going to move that over 2, 1, 2. And then if I look over on the other side at -1, it's at 1. So if I move that over, that goes to +1. And then if I look up, and the next time that it hits is nicely is at 4. So 4, I'm going to move over from 2 to 1, 2. to plus 4. My x equals 4. So here, when x is equal to minus 2, I'm going to add 2 so that x is equal to 0. And I'm going to continue to go through and take each of my points that are nice points and shift them over by 2. And you'll get comfortable, more and more, you will get comfortable recognizing where these points are happening. The more familiar you are with as you practice this more. Remember, I have a really hard time drawing my parabolas on here, so I've plotted my points, and then I'm going to connect my dots really without a smooth line. This really should be a smooth line, but I just am not that graceful on my tablet. And then you want to label your line. You always want to label your lines so that I know that you know which one's which. And that's how you would shift. You can see, even though it's rough, you can see that that whole thing has been shifted to the right. Here, so now part B, I have y equals x plus 3 all squared. So that means that h is equal to minus 3. So we are shifting left 3 units. So the same idea, I have my same parent function, and I'm now moving each of my points to the left. So from 0, 0, I go back 1, 2, 3. So now I'm at negative 3, 0. When I was at negative 1, 1, I go back 1, 2, 3. I'm at negative 4. My x equals negative 4. My y equals 1. When my x equals 1, I'm at 1. So I'm going to move that back 3. And I'm going to continue that with all of my main points that are easy for me to find. Drawing the points really, even though it can be tedious, really helps to make your parabola look better. So if you're having a rough time drawing your parabolas, then plot your points. That really can help you make it not look quite as terrible. Though, as you can see, mine are not, it's not no guarantee, but you can still get the rough shape. I'm not marking for perfection. I'm marking for a general idea. Oh, and then remember, label your lines. Even if you do them in different colors, like mine are done in different colors, if you scan this or if you fax it to me or something, I can't see necessarily those colors anymore. So you still need to label your line. Always label your line. All right, now you can do the support questions on page 5, questions 2 and 3. Okay, finally, we're going to look at A. So A is on page 2 of your IL booklet, and this is y equals the A times x minus h all squared plus k. So for our example, we're going to do y equals 2 times x squared. So A is going to be equal to 2, h and k are both equal to 0. So this is asking the question, what if we multiply the number of squares we have? How does this change our pattern? So if x equals 0, so our side length is still 0, but we're now multiplying our total square area by 2. So the area of a square that has a side length of 0 is 0. So if we have twice the amount of area, we still have an area of 0. If we have a side length of 1, then our area is 1, because 1 times 1 equals 1. But if we now double that, because we've multiplied that by 2, now our area is 2, because 1 times 2 is equal to 2. If x is equal to 2, our area, y is equal to, so our first square is 2 times 2, so 2 squared is 4, but we've doubled our area. So now we've doubled our number of squares. So now we have an area of 8. So when x is equal to 2, y is equal to 8. When x is equal to 3, our side length is 3. So our area is 9, because 3 squared is 9. So then if we double our total area, because we multiplied it by 2, 9 times 2 is 18. So our total area is 18. If our side length is 4, then our square area is 16. So if we double our area, it's 32. Then we plot that, we can see that we have our parent function y equals x squared in black, and then we can see each of our points has been doubled. So 0 doubled is still 0, but for y equals 2x squared, when we get to 1, now we're at 2. When we have, before we were at 4, now we're at 8. When we were at 9, now we're at 18. So we can see that we're increasing faster. Our parabola is going up faster and faster, quicker. So looking at on our shifter, we increase our a value, we can see our parabola gets thinner and thinner and thinner. So this is called a vertical stretch, and it means as our a value gets bigger, our parabola gets narrower and narrower, and that's the first part of the a value. So if a is greater than 1, it is narrower. And if a is between 0 and 1, it gets wider. I didn't actually show you that. So you can see as my a gets between 0 and 1, if it's a fraction or a decimal, you can see that my parabola has gotten very wide. We don't spend too much time with this, but generally if your a is greater than 1, it's narrower. If it's a decimal or a fraction between 0 and 1, then it's wider. The second part of a is what happens if a is less than 0. So looking at that, if a is less than 0, we can see that we get a reflection. So when our a is negative, then still if it's less than technically -1, we're still getting narrower. If it's between -1 and 0, we're getting wider, but we're reflecting. So it's a mirror image into the negative values. So it copies the parent function into where all of our values are now negative instead of being positive. So it's opening down. That's how we call it, opening down. So it is a vertical stretch, but it's also the value is a vertical reflection. So when you have a positive a value, it opens up. And when you have a negative value, it opens down because it's reflected down. And that's what we focus more on in your IEL booklet, but it's still important to know the other part too. So for your practice questions, number 3, state whether the parabola is opening up or down and what the a value equals. So part A, y equals 4 times x minus 3 all squared plus 6. So a is equal to 4. It is this number that is at the front of your multiplying by x and whatever x is adding or subtracting to, and it is positive, so that means that it opens up. That is all that you are required to answer from your booklet. That's all it asks, but because it's greater than 1, this is also going to be narrow, just to know the most. So when here we have y equals negative times x plus 25 squared plus 100. So here our a is invisible. We just have a negative. If we don't have a number and it's just negative, that means that it is -1. So that means because it's negative, it opens down. And because it's 1, it isn't wider or narrower. It is the same as the parent function. C, we have y equals x minus 17 squared plus 42. Again, a is equal to +1 because there's no number there. So that just means that we don't write the +1. We don't write the 1 if we don't have to. Mathematicians are lazy. We try to simplify things as much as we can. So this means it is positive. So that means that we open up. And here d, y equals -1 times x plus 5 all squared minus 50. So here a is equal to -1, so it opens down. And that's how we find our a. value. So if we are going to graph the following function, this, we don't have to, this is, we're just going to sketch. So it's not going to be perfect, and that's going to be okay. So a equals, sorry, for part A, y equals 0.5 x squared. So a is equal to 0.5. So it is positive, so it opens up. And it is between 0 and 1, so it's a wider than the parent function. So for this, it's okay that you don't need to plot the points. We're not learning how to do that exactly. So we're just going to sketch a parabola that is wider and opens up and label it. And so that is all we need to do to sketch for this function. For part B, y equals -3x squared. So a value is -3, so it opens down. And it is greater than, a is greater than, sorry, that's negative. A is less than -1, so it's going to be narrower. So it's going to open down. Again, we're just sketching it, and it's going to be narrower. It is totally okay that this is not perfect. That's not where we're focusing our time right now. And label it. And that's how you sketch A. So now you're able to do the practice problem on page 3, question number 1. So then the final piece, almost the final piece, is putting the pieces all together. So we have moved each individual pieces, but if we change A, make it positive, greater than 1. If we change H, make it positive, so we're sliding it over, and we change K, make it negative, which means that we're sliding down, we get a new parabola, and we get a new equation. So every single parabola you can get by modifying these 3 values. And that is how all of our parabolas are created. So again, I will link in this website in our show notes, so you can go and check that out if you want to. But we're trying to figure out how we put all of the pieces together. So first, there are other quadratic forms. So there's the standard form, and you don't get the same information. So when you have x squared plus x plus something, so here we have y equals 5x squared plus 2x plus 10. Because we don't have those brackets, we don't know our h and our k. We cannot find our h and our k. So you can change this, but you can't actually find the h and the k from this form. From your factored form, again, where we have y equals 4 times x minus 9 times x plus 7, again, we cannot find our h and our k. We cannot find it from this form. So our vertex form is the form that we've been using, which our general form we've been using, y equals 6 times x plus 3 all squared plus 8. So here we can see that our a is equal to 6, our h is equal to -3, and our k is equal to +8. Sorry, a is +6. So this is the only one that we can actually find all 3 from. It has to be in this form. That's just really important to note. So we are getting short on time, so we're just going to skip through these examples, and we're going to practice graphing with all of this information. So we have y equals x minus 3 squared plus 1. So that means that a is equal to +1, so it opens up. H is equal to +3, so it shifts right. And k is equal to +1, so it shifts up. So how I would do this is I would take my I would start at my vertex, which is my corner of my parabola, and I'm going to move it over 3, 1, 2, 3, and then I'm going to move it up 1. And that is my first, I've moved my vertex to this point. So each of my points again, I'm going to move over 3, 1, 2, 3, and up 1. 1, 2, 3, and up 1. So this is how every parabola, how you can figure out what every parabola looks like, is by taking all of your points and shifting them over based on what you figured out from your A, H, and K values. So again, I'm just going to, I did that one wrong. So sometimes when you're looking at it, you're like, wait a second, that doesn't make any sense. And you can go back and you can check and you can see that I actually made a mistake. So it's super important to, if something doesn't look right, then check your work. I made a mistake, it happens. And label your graph. So you can see that this graph is now different, and by using my H and K values, I was able to shift it over and up, and it still opens up. So another example, B, y equals -3 times x plus 8 squared minus 9. So A is equal to -3, so it opens down. And H is equal to -8, so it shifts left. And K is equal to -9, so it shifts down. These aren't always going to always be all positive or all negative. They're just the way that I did it this time. So again, starting at 0, we're going to say we're going to shift left 8. So 1, 2, 3, 4, 5, 6, 7, 8, and down 9, all the way down here. And then we're opening down. So that means that we're opening in this direction. And because we're narrower, we're just going to sort of guesstimate and draw it like that, which is fine. And I zoomed in, and I didn't mean to, and now I zoomed out. Sorry, my computer is having a mind of its own, and I don't know how to stop it from having a mind of its own. Oh dear. Awesome. Everybody's favorite. Okay. So again, always label your graph. Okay, so then we're going to do one quick application question. So a basketball was thrown upward. The basketball's path was given by the relation y equals -0.2 times x minus 2.5 all squared plus 4.25, where y is the basketball's height above the ground and x is the basketball's horizontal distance from where it was thrown, both of these in meters. So what is a basketball's greatest height above ground? So we are going to sketch this. And as we're sketching it, it does not need to be precise, just kind of like open number lines. We're going to do open, we're going to be thinking about it sort of an open concept, right? So we remember I'm going to draw over here. My parent function looks kind of like this. So A is equal to -0.2. So it's opening down. H is equal to 2.5, so shifting right. And K is equal to plus 4.25, so shifting up. So that means that my ball, so I'm starting my vertex, I'm going to shift right 2.5, so approximately here, and I'm going to shift up 4.25, so approximately here. Again, we're just sketching, so it's okay. And then I'm opening down. So that means that it goes down something like that. And if we think about that, that makes sense. A basketball, we start from here, we throw it, goes up, goes to a highest point, and then it comes down. That is how a ball would move. That makes sense. So the greatest height, how high does it go up? Well, if we look here, our greatest height is at our vertex. Well, our greatest height is, did it again. Greatest height is 4.25 meters for part A. And part B was the basketball's horizontal distance when it is at its greatest height. So how high does it go? How far does it go? It goes over 2.5 meters. So using that vertex helps us figure that out. These problems are a little bit tricky. The easiest thing to do, what I find them most useful, is to draw yourself a picture. So draw yourself a picture and try to make it make sense. All right, so we're going to quickly consolidate, remembering that A is the opening of the parabola. So if it's greater than 0, it opens up. If it's less than 0, it opens down. H is the horizontal shift. If it is greater than 0, if it's positive, then it shifts right. If it's less than 0, if it's negative, then it shifts left. And K is a vertical shift. If it is greater than 0, if it's positive, then it shifts up. And if it's less than 0, if it's negative, it shifts down. So hopefully now you are comfortable figuring out where the A, K, and H values are in your equation. And you can explain the difference between a vertical reflection, a vertical.
If you have any questions or concerns about this lesson, please reach out and contact me. Give me a call at the office at 807-737-1488 or toll free 1-800-667-3703. Send me an email to bronwyn.slate, that's spelled BRONWYN.SLATE @nnec.on.ca. Connect with me through Facebook at bslatewahsa. And remember, my YouTube channel is also called bslatewahsa. All of our course material and supports are found under a playlist called MBF3C. So you can find all of our recorded lessons there to support you. My office hours are Monday through Friday, 8 a.m. to 2 p.m. And I'm willing to negotiate a time to meet outside of those hours if need be to give you the support that you need. Thank you so much for joining me today. Mogich.